Hi everyone, thanks for joining this webinar today on Slick 2.0. I'm James Ward from Typesafe. We'll be getting started in a couple minutes. We're going to open up some polls that we'll go through, and that will give us some time to make sure everybody can get on and get their audio working. So we'll be back in just a couple minutes, and in the meantime, fill out these polls. Thanks. Second poll, we're curious to know which relational data access libraries you're using. And second to last poll, what are your plans around NoSQL? And the final question we have for you is, what kind of application are you or will you use Slick in? All right, thank you everyone for filling out this poll so we can get a better idea for who's tuned in today. So if you're just joining us, this is the Slick 2.0 webinar. And this webinar will be recorded. We'll be posting the recording on our YouTube channel. That's Typesafe Hub on YouTube. And that'll go up in the next day or so. And we will email all of you a link to that. So that recording will be up soon. And during this webinar, we will be answering questions. If you have any problems with audio or anything like that, feel free to put those into the questions pod. And then if you have any just general questions about what Stefan will be presenting, put those into the questions pod as well. And at the end, we'll have about 10 minutes or so for Q&A, and we'll go through those questions at the end. So with that, let us know if there's anything we can help with. And I'd like to turn it over to Stefan, who's the creator and lead developer of Slick. All right, Stefan, take it away.
Thank you, James. Okay, good morning, everyone, or good afternoon. I'd like to present to you today Slick, the Scala language integrated connection kit. In particular, we'll be looking at the new features and the important changes in the Slick 2.0 version that we just released a couple of weeks ago. So Slick started several years back as the Scala query library that I worked on since 2008, and it's now a project that is developed at Typesafe and at EPFL here in Lausanne, Switzerland. And it's an open source database query and access library for Scala. We support a number of open source and commercial databases. In the open source Slick core package, which is available under a BSD license, you can find the drivers for Postgres, MySQL, and a number of popular embedded Java databases like H2, HSQLDB, Derby or JavaDB, which comes with the JDK. Also SQLite, which is available as a C and a Java version, and also on Android. And in the commercial package, we have the drivers for the big three commercial databases, Oracle, DB2, and SQL Server. You may have noticed there's another database on this sheet, which is Microsoft Access. We're currently supporting that sort of, so the JDBC ODBC bridge, but that is going away in JDK 8, and we haven't seen any real interest in continuing this so far. So just a reminder here at this point, if you're actually using Access with Slick, or if you're interested in using it, please let us know so that we can decide whether it's worth keeping this and maybe moving it into the closed source Slick extensions and basing it on a proper commercially available JDBC ODBC driver. Okay, so first of all, what is Slick all about? It's a database access library, so you might be thinking it's something like an ORM, but we're actually trying to do something a bit different, which is not object relational mapping, but functional relational mapping, because it's a lot easier and a lot more seamless to map your database queries and your database access to a functional design than an object-oriented one. So instead of using SQL or its modern-day variant JPQL, or maybe the criteria API in Hibernate, you will be using Scala to write your database queries and define your database schemas and other related things. If you look at this simple line of code, you've all seen that before in Scala. For p from persons yield p.name. It's just a call to map written in a fancy way as a for comprehension. And it looks kind of like a familiar SQL statement. In SQL, you would write select p.name from person p. And of course, it does exactly the same thing. Both describe projections. So if you write the first in Slick as Scala code, it will generate the corresponding SQL statement for you. And this approach scales nicely. Here you can see a more complex example. You have different operations in there. In red, you can see operations on collections like filter and plus for concatenation, group by, map, length, and since we're using a for comprehension, it implicitly uses filter, map, and flat map. And you can also see operations highlighted in blue, which are done on primitive types like starts with on strings, or the less than or greater equal than operators on int or long values. These are not really the operators you think, but we'll get to that later. But semantically, they are the same. And below that, you can see the statement that Slick created for this code. This is, except for the formatting, taken one-to-one from the output generated by Slick. So I mentioned we're doing functional relational mapping. Now, that means that Slick embraces the relational model. So the kind of entity you're going to use in your Scala code actually corresponds to the entities in the database. So you're mapping your database tables directly into Scala. Also, if you're using something like sequences, these can also be mapped one-to-one into Scala code. For example, here you see a class suppliers, which extends table of some tuple type of 3 columns. So that's a suppliers table in the database, and it has 3 columns, and we map that to a Scala class that represents a row of that table. And below that, you can see the statement sub, which is supposedly an instance of suppliers, dot filter with some criteria, plus another filter call. These calls like filter and the plus are simply the filtering or restriction and union of the relational algebra. So we can translate these operations directly into database operations. What you also get are composable queries. By writing your database queries in Scala, you can use any kind of Scala features for abstracting over them that might not be available in SQL. Think about how you would abstract over a collection valued query in SQL that you can parameterize. You cannot really do that. If you don't need the parameterization, you can write a database view that always gives you the same kind of data. But if you want to parameterize that directly, then you'd have to drop down into some custom language in the database, for example, PL/SQL for Oracle. But that is not standardized, and more importantly, it's not a functional or declarative language, it's imperative code. So when you use that in another database query, your database optimizer has no way of optimizing that query globally. It can only optimize the outer part of it, then run your imperative code inside, and then optimize possible subqueries that you execute. Contrast that with Slick. You just write a Scala function for abstracting over your query, like we see here, this function f, which takes two IDs and then just executes or composes the query that we saw on the previous slide. And if you use that in another query, val q equals f of 2, 5, you get a new query, and you can compose that further, like here we're doing a map and project out the name field of whatever we get here out of this query. And in the end, Slick will compose a single query and create a single SQL statement out of that, which can be optimized by the database. What you also get as possibly the most important advantage over the ORM model is an explicit control over statement execution. The biggest performance issue with ORMs is that they pretend that your data lives in memory, which of course is not true. It lives in a database. But you get some object and then you follow some pointers in that object to something else which might not have been loaded yet. So it will trigger database access behind the scenes in unpredictable ways. In Slick, this will never happen. So if you have a query, there are a few explicit operations to access the database and then materialize the data on the client side. For example, calling .run on a query. Most of the operations will build a strict collection. For example, there are others like .list or .build collection, and then you say something like vector, and it will build a vector or an array or whatever you want. And there are streaming operations like for each and fold or getting an iterator, but you will never get a collection that pretends to be fully initialized and will later have to go back to the database. So you always know where and when in your program you hit the database. And along with this comes the fact that you're stateless, so you're using immutable objects on the client side, at least as far as Slick is concerned. If you want, you can still use mutable state on top of that, but for Slick, you always send some immutable data to the database and get immutable data out of it. All the mutability is encapsulated in the database. And these factors taken together mean that you have no, or at least a much lower impedance mismatch than with a traditional ORM. So at this point, I'd like to point you to a nice application called Typesafe Activator. I'm explaining different various things about Slick in this webinar, and if you want to try them yourself, you can use Activator for that. So you just go to typesafe.com/activator and you download a single zip file from there, and you just unzip that somewhere and start Activator. Let's just do that here. And this will open a local web server and a web user interface in your browser. And you can use Activator to as a kind of simple version of a web-based IDE. And in particular, you use it to discover sample applications for Typesafe technologies. So here we see the main screen of Activator and some highlighted samples of code. If I scroll down, there's a Hello Slick application. I'll just click Create, and it will create this application. You can see it's compiling in the background, and it will run the tests afterwards. Everything happens automatically here. On the right-hand side, you can see a tutorial which walks you through the getting started section of the Slick manual or something very close to it. It will show you all the basics of Slick, how to write your queries, how to map your tables, everything basically that I'm explaining in this webinar, you can do yourself here. You can just click to the next page here, and then you have links to files. So we can open this hello-slick.scala file. This is a fully fledged editor, so you can actually edit the code here, do modifications, and then maybe just go to the Run tab, and it's already been run, but we can run it again, and then you will immediately see the output of this. So you can easily experiment with the code as you go along, stepping through the tutorial. You can also move your code into a real IDE. Let's just find that. I think it's here. Yes. We go to open, and let's say I wanted to open this in IntelliJ. Your app has no IntelliJ project files, so we ask Activator to generate them. And now it will tell us how to open that in IntelliJ. So let's just try that here. And now we have the project in IntelliJ, and I could continue editing it here or just run it here in IntelliJ. And also, one thing that Activator allows you to do is to add your own templates. So if you have a good usage pattern for Slick, for example, that you'd like to highlight and share with others, you can just upload that through a web form on the Activator website. Okay, let's get back to the slides for now. First of all, before we go any deeper into the code, I'd like to give you a quick overview of the components of Slick's API. The main query API that you're going to use in Slick is called the lifted embedding. That's the query language you saw on the previous slides. You'll see on a later slide why it got the term lifted embedding. We also have something called the direct embedding, which is an experimental API based on Scala macros. We don't expect that it will fully replace the lifted embedding in the future, but we're still investigating in which direction we're taking this. But for now, for production use, you should use the lifted embedding, and that's what I'm going to show you in this webinar. We also have a plain SQL API in case you need to write your own SQL code, which may well be necessary in some cases that Slick does not cover with the lifted embedding. And it is still much easier to use than JDBC. And all of these query APIs are built on top of a common session management. So you can always connect to the database in the same way and manage your sessions and transactions, no matter which query API you use. A new feature in Slick 2 is the schema model. And we're using that for the code generator, which allows you to query a database for a schema at compile time, like in an SBT build, and then generate code for all your database tables. It's proper Scala code that you put into your project and can check into your repository so that you don't have to write all that boilerplate code by hand if you already have an existing database schema. So let's start with the session management. Before you can do anything useful in Slick, you have to connect to a database. JDBC has two different models of doing that. There's the driver manager and the data source model. In Slick, we have unified these, and you always start with this database object. And it has different methods for connecting to a database. For example, here we see database.4URL, which uses a driver manager. So you just pass it a JDBC URL and a JDBC driver, and it will connect to that database on demand as you ask it for a session. You can also connect to a data source if you use for data source instead of for URL, or if you have an application that runs inside some JEE or Spring container, for example, where you use JNDI, you can use for name and pass that a JNDI name that will point to a data source, so you can configure your data source in your container. When you have that DB object, you use something like with session and pass that a block that will execute within the session. You can see we're marking the session as implicit here, and that's usually what you want to do. Every method in Slick that needs a session, so every method that actually accesses the database, takes that session as an implicit parameter. So you can keep it pretty much hidden from your code and simplify things. If you really want to know when and where you hit the database, if you're not 100% sure, you can also just leave out this implicit keyword and always supply the session explicitly to all calls. So this is the simplest way of doing things. You can also get a session directly and then close it when you're done with it if you have a more complicated scope to manage. But in most cases, with session should be enough. You also have with transaction, and you can set various transaction parameters just like you can do in JDBC. So at this point, you may wonder, if you go back to that slide, how do you write driver-independent code? You can see we're importing something from h2driver.simple._. h2driver is, of course, Slick's driver for the h2 database. And we're importing from that directly. But h2driver is not a package, it's an object, because we're writing Scala code and not Java. You can import stuff from any object. And all our drivers implement profiles. So you could just parameterize a class like your DAO with a profile. In this case, we have a variable called driver of type JDBC profile. And all the features that you're going to use that are implemented by the drivers are defined in JDBC profile. So this will give you access to all the drivers features. And you just import from this driver object instead of doing it globally. If you're working in Play, writing a web application, it's done a bit differently. There you have a top-level DB object, and Play takes care of injecting the proper driver. But it's still the same model. You can also check out the Slick Examples project on GitHub, where we show you the multi-DB example and multi-DB cake example, which show some more context about how you might use that in an actual application. And new in Slick 2.0, we have a proper driver hierarchy. Previously, we had a basic profile and an extended profile, and they were both JDBC based and were pretty much the same. So we just unified them into JDBC profile. We also have an SQL profile on top of that, which assumes that you use SQL for querying, but does not assume that you have a JDBC-based database. Then further up, there's relational profile, which assumes a relational model for describing your tables and columns, but does not assume any query language. And even further up, there's basic profile, which just assumes that you can connect to a database and send a query and insert data, but does not define any of the specifics. So the more specific you want to get, the further down you go in this hierarchy and the more features you get. So as I said, all the drivers that we have in Slick support JDBC profile at the moment. We have not yet taken this into NoSQL territory, but the basics in the architecture are there that you could write a driver for NoSQL databases. So let's get to the code generator. The simplest way of getting all your boilerplate code for tables into your application is by using an existing database that has a schema that you can reverse engineer. And to do that, you just run Slick's code generator. It looks a bit verbose here, but that's because we're embedding it in an SBT project. You would add that to your SBT build. And it's also based on SBT 0.12, so it could be a bit shorter now. The only interesting thing really is that you just run a single class. That's just a command line application with a public static void main, this source code generator. You pass it a Slick driver, a JDBC driver, the URL to connect to your database, and an output directory and the package in which to generate the code. And it will generate you a tables.scala file that contains your whole database schema. So for the purpose of this demonstration, let's assume you did not do that and you want to do it by hand instead. So you need to write these table descriptions for the lifted embedding. Now there are two components to a table in Slick 2. The first is a class that describes the table row, and then you have a value that describes the actual table. Think of this class as a class of objects that you put into some collection, and the value that you define here as the actual collection that contains that. So we're modeling a web application here for coffees that has coffees and suppliers. So we start with a table for suppliers. We have a class that describes the rows of this table, and you can see it has a name in the database that we give here, and it has 3 columns: ID, name, and city. And they're created with by calling a method called column, and you pass it a type of that column and a name, and you can also add some additional parameters. For example, for this ID column, we specify that this is the primary key for the table, and we use the auto-inc flag so that the database will generate this field for us when we insert data. One thing you need in every table is this star projection. That's basically what you get when you say select star from suppliers in SQL. And we have to do the same thing in Slick, but it's more explicit. So in this case, we use a tuple of ID, name, and city, just the 3 columns we defined. And the type here matches the type we give above to the table. You can also use nested tuples here. You can even use HLists or add support for your custom container type. So you're not restricted to 22 columns anymore like you were in Slick 1. Down here we have the suppliers object, which is the actual suppliers table in the database. And we use a convenient macro called tableQuery.apply to just create that for the suppliers row. So one thing you might want to do in many applications is to map your data on the Scala side to some other data type. If we go back here, we see that we're just using a tuple of int, string, and string on the Scala side. That's the type we give here. So whenever you query that table, you get a tuple of int, string, and string. You may want something like a custom case class called supplier, which has, of course, fields of type int, string, and string, but they have names here, so it's a lot easier to use in Scala. And you can do that by writing this case class, and then you pass it to table as the type parameter. And what you need to do is provide a bidirectional mapping between this tuple and your case class. So you just use the mapping operator and you provide mappings for the 2 directions. For going from the tuple to your case class, you call supplier.tupled, and for going back, you call supplier.unapply. These functions are conveniently provided by Scala if you use a case class. You can map to any kind of data structure, but then you might have to write a custom lambda function here. So one more thing you may want to map is the ID. Previously, we used an int for the primary key, which is okay, but if you have many tables and you have many foreign key relationships between these tables, you lose a bit of type safety in Scala if everything is an int, because the compiler will no longer prevent you from linking wrong tables together because all the IDs are just ints. So we would prefer to use a special wrapper class around an int for each table. So for the suppliers table, we define a class supplier ID, which just wraps a value of type int. And we can extend any val, so it's completely free at runtime. It gets erased. It's just there for the type safety. And now we use this in our supplier case class on the client side. ID is now of type supplier ID, and we call column of supplier ID for the server side. There's one more bit we need here, and that's again a bidirectional mapping to tell Slick how to map this type. And we do that by introducing a mapped column type. Again, you can see the 2 directions here. We go from this supplier ID to int by calling .value, and we go from an int to supplier ID by calling a constructor. There was a similar mechanism for this in Slick 1, And you still need to do this in more complicated cases. But if you have a simple wrapper like this, which has a constructor that takes one value and that gets into a field called value, there's a much simpler way to do that in Slick 2. You just say extends mapped to of whatever type, in this case int. And you don't need to write any implicit for this. It will work out of the box automatically. So here we have a different table. This is for coffees, and it contains a foreign key, which points to the suppliers table, because each coffee that we have in our database has one supplier. So we have a supplier ID as a standard column in here, and we call foreign key in a separate method to define a foreign key that links this supplier ID to the ID field in the suppliers table. This will cause this foreign key to actually be created in the database when we use Slick to define the schema, and we can also navigate that in a query, so we don't have to write the join condition by hand. So now that we have the definitions for our tables, we need to create them in the database and get some data in. In order to create them, we just call .ddl on the table queries and then .create, which will take an implicit session and define the tables in the database. You can concatenate multiple table schemas with the ++ operator, which is useful when you have foreign key relationships, so that everything gets defined in the correct order. Slick will automatically take care of that for you. Now, if you look at the code for actually inserting the data, it looks very familiar. In fact, you would do exactly the same thing if you were to insert data into mutable collections in memory. Now this looks almost perfect, except we're still cheating here. We assume that we already have supplier IDs, but if you recall in our schema, we told the database by specifying o.autoinc that the database is supposed to create these IDs when we're inserting data, so we wouldn't want to supply them on the client side. There's nothing that's 100% like this when you work with Scala collections, but we can come close. What you could do even with Scala collections is something like this. You write val ins equals suppliers.map from s to tuple of s.name and s.city. So you write a projection. If you do that with Scala collections, you will get a completely new collection, which has the right type to insert just the name and city, but is unrelated otherwise to the original collection. So when you insert into that, you can insert the right data, but if you insert into ins, it will not affect suppliers in any way. On the other hand, if you do that in Slick, this ins collection is not a collection, but a query. It's just a projection of the original data. So if you insert into ins, it will affect the original suppliers table. The only thing that's still missing is a way to get the auto-generated keys back, because we need them down here to insert the coffees. And we have a special operator in Slick called returning. So we say returning suppliers.map_.id, just like the .map call above, so we can get the ID field out. And now when you do a plus equals, it will return this ID, and we can assign it to a variable and use it down here. So now that we have the data in the database, we can write some queries against it. Here's a very simple one. It looks, again, exactly like a query you would write on Scala collections. So in order to understand what happens behind the scenes and why the lifted embedding is actually called lifted embedding, let's look at the types of this. Let's start with coffees. Coffees, as we defined it, is of type table query of coffees, which is a special case of a query of coffees, where query is the standard abstraction that represents a collection-like thing in the database. So now we're iterating over coffees. We draw something out, and this value C is of course of type coffees, not surprising here. And coffees, that's our table row class. It's not coffee, the client-side thing, it's coffees, the table row class. So C.price is a column of double because we defined it that way in the table row class. Now, since this is not a double but a column of double, that means this operator that looks like a standard operator on doubles is not really the standard operator. It is in fact an extension method. So we add these extension methods to make a column of double behave almost exactly like a real double, so you can use all the standard operators on them. And the right-hand side, again, needs to be a column of double, so there's an automatic implicit conversion that kicks in and lifts this literal value here to a const column. And I think now you get a pretty clear picture why it's called the lifted embedding, because all the values you work in are lifted to either a column or a query, which are both instances of a special rep type which contains lifted values. You never operate on plain Scala values. So if we move on to supplier, that's the foreign key. So we just navigate this foreign key from the coffees instance, and it will give us the join condition. Otherwise, we would have to write s from suppliers if s.id equals c.subid. But we already gave that information when defining the foreign key, so we don't have to repeat it here. We just navigate the foreign key, we get a suppliers object out of it. And now in the yield clause, this is pretty much as expected. We get a column of string and another column of string, and we wrap them into a tuple. This gives us the correct type for our query, which is a query with a rather long type consisting of two parts. There are two type arguments here. The first one is just the same one as down here. It's a tuple of column of string and column of string. And the second one is computed automatically from that. This is the type you get when you execute the query, the type of data you get on the client side. And that's exactly the same, except the column type constructors have been removed. So a tuple of column of string and column of string becomes a tuple of string and string. And when you run that, again, you supply the implicit session, and you get a seek of this client-side type of tuple of string and string. Let's look at two more queries here. It's not, unfortunately, not quite that simple in all cases. There are two operators in particular where you have to be careful. That's equals and unequals. Scala does not allow us to override the standard operators, the double equals and the bang equals operator for equality and inequality. So you have to use the versions with an extra equal sign at the beginning. At least in Scala 2.11, the compiler will provide a warning if you use the wrong one. This is not yet the case in 2.10. Here's another query that looks rather dense. It uses, in fact, the same semantics as a group by on Scala collections. It is not as nice as a group by in SQL, unfortunately, but the types are much cleaner and it fits nicely into Scala. But I want to highlight one thing in particular here. When you group, you get a tuple out of that. The first part is the key. The second part is, again, a collection of all the values in this group. And in this case, of course, it's not a collection. It's another query. That's why we're calling it Q here. So we're projecting out from that, from this query of some structure, and we get a query of some field. In this case, I think it would be a query of string. And we call .min on that. So what is the expected type of that? Well, you could expect the first string from a query of string would just be a string. So since we're in a lifted embedding, it would be a column of string. But what happens if the query does not return any data? Which cannot happen in the group by case, but in general, when you're aggregating, it certainly can. So that's why we use option types in Scala. In the database, you would use null for that. And a solution to avoid nulls in Scala is to use option, and that's exactly what we do in Slick. And you do that in all cases where you have nullable columns in the database. For example, when you define a table and you want to specify that a column is nullable, then you give it an option type instead of the plain type. And whenever the value is null in the database, you will get none at the Scala side. So one more thing, if you need to drop down to plain SQL calls, you may want to use JDBC for that, which is pretty verbose, as you can see here. The only thing we're really interested in is this line here in blue, the actual JDBC string. Select ID, comma, name from person, where name like some parameter that we pass in. And we get this parameter pattern as a string. And that's all we care about. We just want to build a result out of that and execute the thing. So there's a much simpler way of doing that in Slick. So you write your method, you get the pattern as a string, you take an implicit session, which you again pass on implicitly to your list call in here, and then we use string interpolation in Scala. Now this is not really standard string interpolation. This is not the S interpolator that you're familiar with. It is an SQL interpolator that is specific to string. So when you insert this variable dollar pattern in here, it will not just dump that into the query string. So there's absolutely no danger of a SQL injection attack happening here. This pattern actually gets replaced by a question mark. You end up with exactly the same string as here, which gets sent to the database, and the actual value of the pattern is put as a parameter into a prepared statement, just like you would do it by hand. Except it's much simpler to write. Then you just tell it what kind of return type you expect and call .list to get a list of these values out of the database. So what I've shown you right now was all based on Slick 2.0. Now, let me sum up what kind of important changes we did there in case you're familiar with Slick 1. We improved the API in certain important ways, which are unfortunately not always source compatible. For example, the way you define your tables. In Slick 2, you have the separate class and the val that comes with it. In Slick 1, it was a single object, which seems simpler at first, but can lead to several problems in practice, because then it's not always clear whether an object represents the base table or just a specific instance of that, and there are issues with an over-eager optimization happening in the Scala compiler that got in the way. All these problems are solved. Another major feature is the code generator. In Slick 1, you always had to write your table definitions by hand, and then you could use Slick to push these definitions as DDL statements into the database. In Slick 2.0, you also have the option of going the other way around. You start with your database schema and then reverse engineer that and get your Scala code created from that automatically. We also have an experimental feature for query scheduling in there, which we will refine further for the next release. That basically allows you to take tables defined in different databases and write a query across these different databases, bringing together the data from them. So you can write a join and other kind of combinators across different databases, and Slick will automatically split that query up into individual parts that it can execute on the different databases, and anything that remains to be done is done in memory by a query interpreter. We also have the new driver and backend architecture. I already showed you the hierarchy for the profiles that we have now, and along with that comes a hierarchy for the backends. So when you use this database object in the beginning to get a database connection, this is also configurable. This is specific to JDBC, of course. We said database.4URL. That's a JDBC specific way of connecting to a database, and that's because we used a JDBC profile, which also relies on a JDBC backend to go with it. If you have a different profile and write a driver for that, you can have a completely different backend, which only needs a notion of there is something called a database and there is something called a session that you can run in, but it does not specify how to connect to them or what they look internally. This is all up to you if you want to support your own database systems. So if we look a bit further, in Slick 2.1, which we expect to be out sometime this summer in 2014, we're focusing mainly on usability, so we don't have any big features planned. This means we're going to improve the documentation. We want to in particular add chapters that help you migrate from ORMs or from plain SQL usage to Slick's lifted embedding. And we're looking into improving the API documentation and the semantics. There are some long-standing feature requests, for example, for an insert or update feature that automatically determines if an object already exists in the database. These are the kinds of issues we want to tackle for the next release. And the Play team, in the meanwhile, is working on making Slick the default database library for Play 2.3 when you're using it as part of the Typesafe platform. There's currently a separate project called Slick Play, which integrates Slick into Play, and this has been handed over to the Play maintainers for integration directly into Play. Two big topics that have come up previously and that I've shown in several presentations are macro-based type providers and async support. So let me say a few words about these things in the end. We do have a prototype for macro-based type providers. That's basically what you get in F#, if you're familiar with Link and .NET. It's like the code generation feature in Slick 2.0, except it runs inside the compiler, so you don't have to add it to your SPT build or some other build script. It will happen automatically on the fly. Your compiler connects to your database and creates the schema for that in memory. You never see the actual files. We have it working as a prototype, but the evolution of macros in the stable versions of Scala has progressed rather slowly, and we're not sure when we will get the right features in a productive version of Scala that we can use. These are research topics, and there are research branches if you want to try this stuff today. We're also investigating async support, which is important for Play and Akka applications in particular. You don't want to be bothered with a blocking database API when you write a completely non-blocking Play or Akka applications. Now, this may not be 100% possible because the JDBC drivers are still blocking, but at least we want to move the responsibility of handling those blocking operations correctly into Slick itself. So as a user of Slick in a Play application, you don't have to care about that anymore. It will all be handled automatically for you. And we'll also look into the possibility of providing a Java API, because both Play and Akka have Java APIs. So that would probably make a lot of sense for many people. I do not have anything about NoSQL on here. You may have seen that on previous presentations that we did about Slick. We kind of step back out of the NoSQL business for the moment to concentrate on the core, on giving you better support for SQL databases, because there are already some established solutions for NoSQL, and people are happily using them with Play and Akka applications. So for the near future, at least, we will concentrate and focus on the core SQL business and improving Slick support for that. So that is pretty much all I have. I'll hand back over to James for the questions now.
Great, thank you, Stefan. That was really fantastic stuff. And for those of you that didn't hear, we will be posting the recording of this on our YouTube channel. And now we'll take the next 10 minutes and go through the Q&A. So if you have any questions, please post those in the questions pod in the webinar. So we've had a lot of great questions come in. We'll try to get through as many of these as possible. There was a question around having some clarification around the async option in Slick and how that would relate to the possible async JDBC drivers that are out there. So maybe just can you go into a little bit more detail on what that would look like and what its relationship would be to async JDBC drivers?
Okay, so first of all, we want an asynchronous API at the user level for Slick. So when you use Slick in a Play or Akka application, you want to be able to stream your data across seamlessly. So we need to use the same kind of abstraction for asynchronously streaming data in all three projects. This is the most important aspect here. then if we want to go further and provide even better and more scalable asynchronous support, we also need asynchronous database drivers. We can still have the asynchronous API without them if we take care of correctly scheduling all the calls behind the scenes to free you up from that. But going further will require asynchronous database APIs, and of course, the natural first candidates to look into would be MySQL and Postgres, because there's already an open source API for them for asynchronous calls. But we have not actually investigated any time in trying that or benchmarking that. This is something we plan to do in the near future.
Great, thank you. There's a question about, do you have an example of using the HList?
An example for the HList, well, I can point you to the source code here, perhaps. Let me just find that. No, we're in the wrong project. Oops, I shouldn't have opened this here. Okay, going back to Slick. It's a bit slow. Something's wrong. Mapper test. Okay.
So this is in the actual Slick source code.
This is in the Slick source code. We're going to the JDBC mapper test. And this gives you an example for mapping a custom shape, which is even more advanced, where you define your own container. And it gives you an example for using HLists. So you can see you define a table that has an HList type here. And of course, the star projection uses the same HList type. And then when you insert data, you use the HList type for that and use it for querying, just like you would use a tuple type.
Great, that's a great example. Thank you. There's a question about from somebody who's a current Slick 1 user, and they're wondering how Slick 2 helps with the greater than 22 column limits, yeah, so we'll start there.
Okay, so this limit is completely gone in Slick. Of course, there's still a limitation that a single tuple cannot have more than 22 columns, but you're no longer restricted to a single tuple, because you can either use HLists, as you see here, or you can nest tuples. For example, you see that in this test wide mapped entity that we're doing here. We're just in this star projection, we have an outer tuple here, and we have some tuples nested in that. And you can even map that to a case class or a collection of case classes or whatever, or you can use an unmapped version and provide the same type when you define your table. So this should work seamlessly across all of Slick for querying, for inserting, for updating everywhere.
Great, thank you. There's been a few questions about if you have any suggestions for how to deal with schema migrations.
There's a separate Slick migrations project. Let's just Google for that. That was done as a summer of code project. We have it here, Slick Migration API. It's not production ready or done for Slick 2.0 final. It's still a work in progress, and we're investigating what to do about it, whether we want to add it as an official project to Slick in the future. But it may be something that you could check out and see if that would fit your requirements.
Sounds good. There's a question here about how do we deal with preventing SQL injection type of attacks with Slick?
Okay, Slick should prevent that whenever you use the lifted embedding or the direct embedding or the plain SQL queries in the way that I showed you. So when you have some value that you embed in your query, Slick will automatically quote that correctly, at least. That's the minimum you get. And if you use cached queries, where you only compute the SQL statement once, or if you use the interpolators that I showed you for plain SQL queries, then you will even get prepared statements which use variables to pass that. So even if Slick got the quoting wrong, you wouldn't run into any problems because it would never put that value into an actual SQL query string.
Great. That's fantastic. Looking through a few other questions here. Apologize if we won't have time to get to everyone's. We'll try to follow up with you afterwards if we don't get them answered. There's a few questions around NoSQL. Could you re-clarify the plans around Slick and NoSQL?
Okay, we started a MongoDB implementation, but we don't have the resources to follow up on that. And since people seem to be happy with solutions like reactive Mongo, it's not a high priority for us at the moment. So we're really concentrating on the basics. We've tried to build an API in Slick 2.0 for the drivers and for the backends that allows other people to write support for non-JDBC and non-SQL databases that they can add to Slick, but we don't have any plans of supporting any such databases ourselves in the near future.
Okay. So, but the community could certainly add it on their own.
Yes, we expect this should be possible with the new API.
Great. There's a question about if Slick 2.0 is supported with Play currently, and yes it is, and I think there's even an Activator template that is using the current Play Slick plugin with Slick 2.0.
Let me just go back to Activator here and show you one more thing. If we go to the starting page of Activator, we only have looked at the feature templates here, but we can also go to a full overview, and there's a Slick tag here that you can check on the right hand side, and there you can see all our own and all the submitted Slick templates, and you can see two templates, for example, for using Slick with the code generator, and you can also see a template for using Slick with Play.
Great. Speaking of code generator, there's a question if the code generator can handle more than 22 columns.
Yes, we have some support for that. I'm not 100% sure if it's enabled in 2.0 or whether we're doing that now in 2.01, because there were still some issues in the current Scala 2.10.3 which prevented that from working reliably and efficiently, but these should be sorted out in 2.10.4, Scala 2.10.4 and Slick 2.01. So it will automatically generate HList types for you in that case.
It looks like it might already be doing that. I've seen a comment from Christopher, the guy who built that part, and he says that it automatically switches to HList for greater than 22. So,
cool.
So it looks like it should be good in 2.0. If not, then 2.1 for sure. There was some questions around clarifying using Slick with commercial databases and Slick extensions.
Okay, so the commercial databases are supported as part of the Slick extensions package. We're not actually selling that as a separate product, but you need to have a production subscription, a Typesafe production subscription for your server on which you run your application. So the same way as you license your database server with Oracle, but you can otherwise use their stuff for free, you have to do the same thing with Slick extensions. You can download it for free for development and testing purposes, but when you move into production, then you have to get a support license from Typesafe for your server.
Great. Yep. And the thinking on that is that if you're paying for your database, then you can help us fund further development of Slick. So great. We are just about out of time. One last question we'll wrap up with, and that's about debugging. How do you debug queries? How do you see the generated queries and do other types of debugging on with Slick?
So the easiest way to see queries for debugging purposes and also for logging is to turn on the logging. Slick uses SLF4j internally, and you can turn on various loggers. If we go to the Slick project, there is a logback XML configuration where you can see all the loggers that Slick uses internally. In particular, there is one on JDBC backend dot statement. If you enable logging at level debug for that, it will print out all your statements that you send to the database. And you can also enable logging of the query compiler details so that you can see all the transformations it does in there. Also, when you have a query and you want to get the statement in your application, whenever you can query something, you can say .select statement on that and get the statement out. The same when you would call insert, you can also say .insert statement, or for delete and update and so on, you can always get the statement directly.
Great. Well, that's very helpful. Well, we are out of time. I want to thank everyone for attending. We'll be posting the recording in the next day or so on our YouTube channel, and we'll email everyone that link. And if we didn't get a chance to answer your questions, you can feel free to email me, james.ward@typesafe.com, and I can help with that and direct you to Stefan. You can, of course, interact with the list. Is there a mailing list for Slick?
Yes, there's a mailing list. It is on Google. It is called a Scala query, actually, not Slick. But in the description, it's a Scala query / Slick mailing list. And you can also find it on our website if you go there, slick.typesafe.com. And on the community page, you have further links for the discussion groups and for the tags on Stack Overflow and so on.
Great. Thank you, everyone, for attending, and thank you so much, Stefan, for the great presentation, and look forward to seeing you on a future webinar. Thanks. Bye.
Thank you.